it's me. It's not a PowerPoint. That's weird, right? All right. So this video is intended to oh, and don't let the weight set intimidate you. I mean, I know you guys have been noticing the guns all this time anyway, but hey, it's not. It just didn't happen. I have to work on that, okay? But anyway, so this is going to be a video to help you guys review um, your FRQs. These are very important questions, you guys. I've been encouraging you for quite some time to be writing your answers in here. Um, FRQs are the hardest part of the AP exam, so that's where I focus all the attention. Multiple choice is pretty chill, and if you know how to do these anyway, you know how to do the multiple choice, so I don't focus on multiple choice very much. I focus on this because this is where the real difficulty lies. It lies in your ability to solve problems without having answers right in front of you and being able to justify yourself. So if you can do FRQs, you could do the AP exam, and that's why I focus on this so much. Now, as you guys can see, this little booklet here is broken up into topics. Now, every week for this review session, we're going to be just hammering through as many of these things as we can. The most I'm going to be able to handle is probably about 5 a week with you guys or so, but from each section. But anyway, this week we're going to focus on everything else, and we're going to focus on slope fields and differential equations. This is just kind of like a hodgepodge of questions that are random. They're not really special. So I wanted to give you guys some there just to kind of let you get used to the experience of a variety of kinds of questions they can answer. But I can't really teach you much from that other than just say, hey, know your stuff that we've been talking about all year long, because there's no patterns here. But this other one here that we're focusing on this week, slope fields and differential equations, there's some serious patterns in there. And so this video that I'm making for you guys right now is about getting you guys used to these types of questions. You will see one of these types of questions in your exam, and everything I'm going to go over is going to be right on that test. I mean, unless they all of a sudden decide this year, hey, we're going to be completely different than we have been for the past 20 years. But they've been doing this for 20 years. It's like so predictable. So this type of question is going to pop up on your exam, and you want to know how to do it. So this video is really just dedicated to helping you guys know how to deal with the slope field and differential equation FRQ questions and how you can maximize your points. So without any further ado, let's get started on it. So here are the 3 main types of questions that you guys are going to be seeing on your AP exam for slope fields and differential equation FRQs. You're going to probably be asked to write the equation of a tangent line and use it to make a linear approximation. That's usually worth 2 points. Okay, so there's that one. And then you have finding the particular solution. This is the big daddy of it all here. This is where you're going to get a ton of points, and that's worth about 4 to 5 points. And then also sometimes they'll have you sketch a slope field as well, and that's not worth very many points. That's only worth 1. Altogether, you're looking at about 9 points altogether in general on these FRQs. So these are estimates. As you guys can see, it's not going to add up to 9 points necessarily on my sheet here, but it does ultimately on the test depending on the types of questions they ask. So you want to be focusing on getting at least 5 points, and I'll show you how they typically grade you on these things. But this is pretty much what you can expect to see. And as you guys will see, when you're going through your FRQ questions this week, these are the types of 3 questions you're going to see over and over and over. They're on almost every question that they've been going through for the past like 20 years. So very repetitive. So we're going to go through each one of these just so you guys can see an example. And I'll also explain how they grade you on these, which hopefully you kind of already know because I've been asking you guys to grade yourselves on these all year long so you can get used to how they grade. So hopefully it's not too mind-blowing, but good time to review. So here's common question number 1, the tangent line question. So here's the steps for it, and then we're going to do an example. So basically, you're going to plug the given x values into the differential equation to find the slope. And once you have that, you're going to plug a point in the slope to write the tangent line. Then once you do that, you can use your tangent line to make a linear approximation. So we're going to do these 3 things. I might be talking over your head right now, like, what the heck is he saying? But basically, we're just going to find the tangent line and then use it to make an estimation of the function. Another thing to be aware of is the fact that if your tangent line approximation is greater than your function, that means your function's concave down, or the second derivative is negative. Or if your tangent line approximation is less than your function, that would mean your function's concave up, which means your second derivative is greater than 0. And we'll kind of see some examples of that in a minute. Now, this might seem like, what the heck are you saying? Hopefully, after the example, these things will make a little bit more sense. I just want you guys to have some notes to look at. So let's go ahead and take a look at an example here. So example 1, let dy over dx equal y squared over x minus 1, and y equals f of x is the solution. In other words, this is a derivative. What if we integrate that and turn it into a regular function? That would be the regular function. And they're giving me an initial condition here where x is 2, y is 3 for the original function. All right, so question number 1 here wants us to write an equation for the line that is tangent to this function. So this function, which I don't even know what it is right now. I know what its derivative is, but I don't know what the original function is. Please don't draw this on your notes because it's not right, but I'm just giving you an idea. So let's just say the function looks something like this. Okay. Well, what I'm about ready to find is I'm going to find the tangent line to this function at x equals 2. So like let's say x equals 2 is right here. Well, there's my tangent line. So I want to find the equation of that little line right there. Now, once again, don't draw this picture. It's completely wrong. I'm just doing that to give you guys a visual of what we're doing. All right, so how do you find the equation of a tangent line? Well, I think we have it on this last slide over here. You're going to plug the given x value into the differential equation to find the slope. Once you have the slope, you're going to take that slope and the point that you've got, and you're going to plug it into the point slope formula to get your tangent line equation. So here we go. We need a slope, we need an x, we need a y, and once we have those three things, we can plug it all into our point slope formula, which looks like this. Now you guys are like, oh, okay, I know what you're talking about now, Mr. B. That should look really familiar. We've done that quite a bit. So it says write an equation for the line tangent to f of x at x equals 2. Well, something that's kind of important to understand is that when x equals 2, that means y equals 3. How do I know that? Because it says it right here. When x equals 2, y equals 3. So that's kind of a sneaky little thing there. They're telling me the x, but really by telling you the x, you also know the y. And that's important because if you want to find your slope, you have to use your derivative, which is dy over dx is equal to y squared over x minus 1. So if you want your slope, you need to know both y and x. So I actually do know both of them. The x goes here, and the y goes here. And that ends up giving me a slope of 9 over 1, which is just 9. So there's my slope. All right, so to find your slope, you need to plug in the x and or y value that they give you to find the slope. You plug that into your derivative, right? Now we're going to go with the x and y value they gave us. My x value is 2, my y value is 3, right? So now we're just going to go ahead and plug that into our point slope formula, and we'll have our tangent line. My slope was 9. My x1 value is 2, and my y1 value is 3. Now, these x's, I should put a 1 here because I want you guys to know where they go in the formula. In the formula, they go here and here. They don't go for this y and this x. They go for the ones that I put a little 1 next to. So we'll call these x1, y1. And I would go ahead and simplify it. It's not that hard. You know, if I was really taking the AP exam, I might have just stopped right here. But I already know that I'm going to use that in the next few steps. So since I'm going to use this equation, I want it to be simpler. So I'm going to go ahead and go the extra mile here and simplify it. So I'm going to distribute the 9. That's going to give me minus 18 plus 3, which is minus 15. So there's my tangent line. So remember, once again, don't draw this picture. It's completely false. But if my graph looked like this, I said we were finding the tangent line at x equals 2. We said it would look like this. That straight line right there, that would be this equation. Now, how do they grade you on this? Usually, they're going to give you 1 point for finding the slope. So if you got 9, you've already got 1 point. And then they're going to give you another point for having the correct tangent line, which is here. Now, just so you know, let's say you simplified it, but you simplified it wrong. you had it right here but not here, you lost your point. That's why it's kind of a good idea to stop while you're ahead. But like I said, on this problem, I know I'm going to need to use the simplified one anyway. It's just easier. So I'm going to go ahead and simplify it. But you know, I guess to be safe, why don't we'll just sit down, don't do it. Just leave it. We won't do the 915. We'll just leave that. The less work you do, the better, okay? That way we don't make any mistakes. Right, so there's my equation of my tangent line. 1 point for the slope, usually 1 point for the tangent line. And that's a 2-point question right there. Now the next thing that this problem is asking us on part B is they're asking us to use that tangent line to make an approximation. So let me explain what we mean by that. So the tangent line touches this function at a point. And as you guys can see, anytime that tangent line is really close to the function, this straight line is very close to this curve so long as we're really close to that point of tangency. So a tangent line can be used to estimate the y value or even the slope of your original function so long as you're close to this point of tangency. It won't be exact, but it can be slope, but close. So for part B, what I want you to understand is we don't know what f of 2.1 is because we don't even know what f is. I don't know what the function is at this point. All I know is its slope, and I also now know, because of number 1, what the equation of this tangent line is, but I don't know what the original function is. So how can I find out what the f of 2.1 is if I don't even know what f is? Well, f should be approximately, so I'm going to make wiggly equal signs, it should be approximately equal to y of 2.1, where y is the equation of my tangent line. Why are these approximately the same? Well, this tangent line is at x equals 2, and 2.1 is really close to that. So this tangent line should have the same output as my function, pretty close anyway, at 2.1. They should be really close to each other. So since I don't know what f is, but I do know what the tangent line is, I can estimate what f is by plugging 2.1 into my tangent line equation instead. Now, if you have the simplified one, you can leave it simplified. But let's just say I didn't, and I left it unsimplified, so it looks like this now. But basically, I would just be plugging in 2.1 in for the x. And so from here, we're just going to go ahead and go through it. That's going to give me 0.1 times 9. And then 9 times 0.1 is 0.9. And then 3 plus 0.9 is 3.9. And there's my answer. So f of 2.1 is approximately the same thing as y of 2.1, which is 3.9. And there's our answer. Now that's usually going to be only worth 1 point, just so you guys know. All right. There's a lot of concept in there, but they can't grade your knowledge of the concept. They just grade the answer that you get. You do need to show your work. You couldn't just do all that mentally. I would highly advise you guys show your work. At least you would want to write this, I think, because that shows them that you understand stuff a little bit. Maybe doing this in your head is a possibility, but just to be safe, why not just show it all? I mean, doing work in your head results in errors anyway. But that there is going to be worth about 1 point. Okay, so you can estimate the value of your function using your tangent line. Now, a lot of times these questions are put together as one question, though, just so you know. So a lot of times they won't say, for question 1, find the equation of the tangent line, and then for question 2, now use that to estimate f of 2.1. They'll just say, use the equation of the tangent line at x equals 2 to estimate f of 2.1. That's how they'll do it. They'll put it together as one big question. But that means you do need to do 2 separate things. You need to start by finding the equation of the tangent line, and then you plug it in. Okay, so I like to I break it up for you guys just so it's easier to understand. But there you have it. Now let's go ahead and take a look at our question here. Now f of, let's take a look at C. Is f of x concave up or concave down at x equals 2? Explain your answer. Now, the way I drew my picture, it looks like at this point my f is concave up, but that's not right because, or it might be, but it might not be. Remember, I told you I just made this picture up. This may not be a good picture. But basically, this is where this part comes in kind of handy back here. if your tangent line gives an estimate that's greater than your function, what would that look like? Here's my tangent line. If that's greater than my function, that means it's above it. And the only way that's going to happen is if your function is concave down. So if your tangent line gives an answer that's greater than your function, that means your function is concave down, which means the second derivative is negative. Now, if your tangent line is less than your function, that would mean your function's above the tangent line. And the only way that's going to happen is if f is concave up. So if f is concave up, that would mean your second derivative is positive. So now let's go back to the question then and take a look at this. Right, so I'm going to need, I actually had to change the question a little bit. I left some information out of it. So now let's answer this question. Let's say if f of 2.1 equals 4, the question now is f of x concave up or down at x equals 2? Well, here we go. We did our estimate on part B, and our estimate was y of 2.1, right? And our estimate of y of 2.1 was 3.9. But now they're telling us that, okay, cool, but the actual answer, which we didn't tell you before, but the actual answer of f of 2.1 is 4. So here's our estimate, but here's the actual answer. And as you can see, the estimate is less than the actual amount. And what that means is that your tangent line is below your function at that point. Now, if your tangent line is below your function at that point, that would mean that you could say this in, you would say that f is concave up. Now, if this arrow was facing the other way, then that would mean f is concave down. Now, another way that they could answer this question or ask this question is instead of asking you is f concave up or down, they could ask you is the second derivative positive or negative. In that case, for this one, you would say f double prime is positive, and that's because when f is concave up, that means the second derivative is positive. So there you guys have it. That's how you can tell. This question here is not real common. It's not as common as these two. You're more than likely going to see one of these two questions. They'll probably put them together as one and make it a 3-point question, but this is very common. I've seen this on a couple FRQs, but not a whole lot. But it is helpful to know that if your estimate is less than the actual value, your graph is concave up and the second derivative is positive. Or if your estimate is greater than the actual value, that's the opposite is true. Okay? So let's go ahead and move on to common question number 2. Now this is where you earn a ton of points. So this is one that I've encouraged you guys way back in September. Practice this one. Practice, practice, practice. Get really used to it because this one is going to guarantee you a pass on at least this question of your AP exam, just knowing this one type of question. And a ton of these steps are actually pretty simple. Step 1 is pretty simple. Step 3 is pretty simple. Step 2, depending on how well you know how to integrate, may be simple or not. It just depends on how good you are at integration. Step 4 is the tricky one also. But the good news is, if you've already done steps 1 through 3, you've already gotten most of the points anyway. So this is a great question to know. But here's the steps on how to find a particular solution. Separate the variables, integrate both sides, and don't forget your plus c. Find the c value, and then solve for y. So here's an example. Let's go ahead and go through this one really quick. So step 1 is well, let's read the question first. Let dy over dx equals y squared over x minus 1, where y equals f of x is the original solution with an initial condition f of 2 equals 3. Same problem as the last one. This time they're asking for us to find a particular solution, and when you see that, that's when you're going to do the steps that we just reviewed on the last slide. So the first thing you're going to do is you're going to separate your variables. So I want all of my x's on one side and all of my y's on the other. So the first thing I would do is I would multiply both sides by dx. If I do that, it's going to look like this. The dx on the left side cancels. And then on this side now I've got my dx. But I don't want that y squared on the right side, so now I'm going to divide both sides by y squared. And if I divide both sides by y squared, that's going to look like this. The y is no longer on the top, so I'm just going to put a 1 there now. We got that. So the first thing I did was I multiplied both sides by dx, and then I divided both sides by y squared. Now you have to know how to do algebra here because it's not always going to be the same, but you probably will end up doing some kind of multiplication or division, okay? It's not going to be, it'll be one of those two things, okay? Either multiplication or division. But the point is get your y's on one side and get your x's on the other, all right? Now if you can do that, right away you've already gotten 1 point. Okay, now let's move on to the next step. The next step is to integrate both sides. So we're going to integrate both sides. Now at this point, if you know your integration, you're good. If you don't know integration, you're going to have some trouble. So for the 1 over y squared, well, anytime this power is anything other than a 1, the first thing you're going to want to do is rewrite it so that you have a negative power here instead. Over here for this one, this is going to be a u sub problem on this side. So let's start with the left side here because it's a little bit easier. To do this one, the first thing I'm going to do is I'm going to add 1 to the power. Now, if you add 1 to a -2, you get -1. And then you also divide by that value. And we're done. I've integrated it, okay? But I do want to rewrite this. I want to simplify it a little bit, okay? So first of all, I don't like negative powers, so I'm going to put that y to the first power on the bottom with that -1, and that's going to leave 1 on the top. Now, this is kind of an ugly looking fraction. If you have 1 over -1, that's really just saying basically -1, right? So here's the easiest way to rewrite it. Just put -1 over y. Okay, so now let's go ahead and do this other side. This other side over here, to integrate this, we're going to want to do some u substitution. The u is x minus 1. The derivative of u with respect to x is 1. And so if you want to get dx by itself, which is what you need to do at this point, is you would need to multiply both sides by dx, and that would give you du equals dx. And so we can go ahead and do our u sub. So now we have 1 over u du. Now when you want to integrate this, notice that the power of the u on the bottom is a 1. Now that's not a reverse power rule, so I'm not going to move this up to the top and call it u to the -1 power. This is actually an ln problem. When you integrate, you put ln of the absolute value of u, and you don't want to forget your plus c. You'll notice I didn't do a plus c on this side. You don't need to do it on both sides. You just need to do it on one side, and I just do it on the side that has the x just because that's how I choose to do it. But you only need 1 plus c there. Now that I've got that done, we want to do our back substitution now. So I'm going to replace the u with what u equals. U is x minus 1. All right, so right there, we just added 2 more points. You get 1 point for integrating one side and 1 point for integrating the other side. So now we're up to 3 points total, okay, for this one question. All right, now the next thing you do after you integrate both sides is you want to find your c value. And the way that you do that is by plugging in your initial condition. So I'm going to plug 2 in for x and 3 in for y, and that way I can solve for c. So I have -1 over 3 equals ln of the absolute value of 2 minus 1 plus c. Now, 2 minus 1 is 1, and ln of 1 is 0. So this whole thing just goes away, and I'm left with c equals -1/3. So now I've got this equation. Here's my general solution, but I just found c, and c is -1/3. Awesome, right? We're doing really good. All right, so that's +1, another point, being able to find the c. So step 1, separate the variables, that's 1 point. Step 2, integrating both sides, that's another point, 2 points actually. Step 3, find the c, that's another point. And step 4 is to get the y by itself, which is our last point. Altogether, you're looking at 5 points. Now, what's crazy about that is that if you get this one question right, even if you got the first few questions wrong on your FRQ, but you got this one question right, you've already gotten, that would be like passing that FRQ question. You're good. So this is a fantastic question to know how to do. It's long, it's tedious, but they're almost all the same. And so, gosh, why not just know it well and guarantee a pass? So these are the ones you really want to focus on. But let's go ahead and do our last step here. The last step is to get the y by itself. How do you do that? Well, I don't like how this y is upside down, so the first thing I'm going to do is I'm going to flip it over so it's y over 1, which means it's just y, but the negative's still in the front. But if you're going to flip the left side over, then you also need to flip the right side over, so that would look like this. Now, this is not the most simplified way of writing this, but I don't care. When it comes to FRQs, you don't have to have things in simplified form. You could try to simplify this, but I wouldn't. You're probably going to get something wrong if you do. Just do it. I just did the reciprocal on both sides, and we're good to go there. All right, the next thing that we're going to do is I'm going to get rid of that negative in front of the y by multiplying both sides by a negative. And so if I do that, I end up with a -1 on the top, or you could have just put the negative in front of the entire fraction here, like a big negative here. That would have been fine too. And in fact, maybe that's less confusing for you guys. So we'll just put a negative right there in the front. But there it is, and we're done. That is the answer, and that's your last point for a total of 5 points on that question. So that's a really important one. If I had to ask you guys to get one down this week, it's that one. So make sure you guys know how to do those well. All right. The last thing that I'll go over with you guys here is sketching slope fields. So sometimes on the AP exam, they're just going to give you some tables here, and they're going to ask you to sketch some slope fields at particular points. You're just going to plug the coordinates of each point into the derivative and sketch a slope that corresponds to the derivative at the indicated point. Now, my hint to you on these ones is try to do these ones quick. These problems can take a really long time if you aren't quick about it, and it's kind of silly because they're only worth 1 point. So try to do as much mental math as you can, and don't spend all your time writing down all your calculations. It should be quick and easy enough to where you can just do it in your head and then just get your sketch on there. The only thing that they're really going to be checking on, because when it comes to sketches, it's like, well, you could be a little bit off. So all they're looking for is if you should have a positive slope at this particular point, make sure it's a positive slope. If you have a negative slope, make sure it looks negative, and zero slope should look flat. So really, if your positives look positive and your negatives look negative and your zeros look like zeros, then you're going to probably get the credit. I mean, now technically they can get kind of picky. So like if you had like a +2 and a +1, a +2 slope should look steeper than a +1 slope. Sometimes they can get picky about those kinds of things as well. But notice they're both positive. They're both going upwards as we move to the right. That's probably your best bet to focus on. But yes, technically bigger numbers should look steeper, smaller numbers should look flatter. So let's go ahead and give it a shot here. So now we're going to assume here that this slope field is the same differential equation that we had earlier, which was y squared over x minus 1. Okay, so I want to do this one here. Now I'm going to show my work for the first one, but after that, we want to do all this mentally. You don't want to be doing this stuff by writing it all out. So if I want to find the slope at this point, first of all, you need to know what the coordinates are. The coordinates are 0 and 2. That means I'm going to plug 0 in for x and 2 in for y. And so that's going to be 2 squared over 0 minus 1, which is 4. So notice that that's a positive slope. So you're going to want to make sure that your slope at that point is going in an upward direction, and 4 is a pretty big number. I would make that look really steep. There we go. Now I'm going to do the rest of them mentally. So this point here is the point 2, 2. So if you plug in 2, 2, you're going to end up with 4 over 1 again, so it actually is going to look the same. It's going to be parallel to the other one. Next point I plug in is going to be this one here, which is 0, 1. So if I plug in 0, 1, I'm going to end up with, oh, you know what I just realized? This first one here was supposed to be -4. So that means it's actually going to look the same as I had it. It's just that it's going to be opposite direction. It's going to be going like this. So my bad. I screwed up on that first one. That one should be a negative slope, but the second one, this one's right. That one's a positive slope. All right, back to this one, 0, 1. Plugging in the point 0, 1, I'm plug 0 in for x and 1 in for y. That's going to end up giving me a +1 slope. So it's going to be a positive, or -1, I'm sorry. It's going to be negative like this one, but it's going to be a lot flatter because -1 is less of a number than 4, right? Now if I plug in 2, 1, I'm going to get, let's see, 2 on the bottom is going to be 1, and 1 on the top is 1. So it's going to be a positive 1. Same thing, but opposite direction. That one's going to be a positive slope of 1. And then we have 0, 0. That's going to be a flat slope. And 2, 0. That's going to be a flat slope also, because you're just going to get zeros. And so that's all they would be looking for. They would want to see, did the person make sure they had negative slopes here and positive slopes here? Did they get zeros down here? You'll probably get the points at that point. But they might also get picky and be like, does this slope look a little flatter than this one? And if you got all those things in place, then you're going to get your +1. Pretty easy, pretty straightforward. Don't spend too long on it. And that's it. So that's it for our FRQ review for this week. I love these slope field and differential equation questions because they're very predictable. You guys will see one of these questions and it will definitely have this 1 and 2 on there. It will definitely have this type of problem on there. It could have a few of the other things that I shared with you. They have this quite often as well. So very predictable, very easy to prepare for. So make sure you guys do well with your FRQ Blue Book practice. All right, so that's it for now, and we'll talk to you guys later.